Assalamualaikum and hi everyone. So previously we talked about rigid and non-rigid diatomic molecule which consists only two atoms. So now we are focusing on linear polyatomic molecule that consists of more than two atoms. For example, OCS and Hc triple bond CCl where atoms lie in a straight line. So if you remember, the first thing that we talk about is the principal moment of inertia. So for example, in OCS, we have IA, which is the principal moment of inertia about the bond axis, and IB about the plane, and IC is the one that perpendicular to IB and also to IA. So IA here, since it's the rotation about the bond axis, IA is equal to 0, and then IB and IC has a value where IB is equal to IC. So in linear polyatomic molecule, the energy level equation are the same as the one in non-rigid diatomic molecule, which is equal to epsilon j bjj plus 1 minus dj square multiply in bracket j plus 1 square with the unit of per centimeter or centimeter to the power of minus 1. So the thing about linear polyatomic molecule is this one is our limitation. We have a difficulty to measure the bond length in linear polyatomic molecule. So for all linear molecule, since the moment of inertia for the end over end rotation of a polyatomic molecule is considerably greater than that of a diatomic molecule, the B value will be much smaller and the spectral line more closely spaced. So now remember that if you have diatomic molecule, the moment of inertia, the inertia is given by IA plus IB. Okay, but now if you have three atoms, for example, you have A, B, and C. Now the sum of inertia is equal to IA plus IB plus IC. Therefore, the value of inertia in linear polyatomic molecule is much greater than the diatomic molecule. So, and then if you remember that I or B is equal to H pi a square IC. So if you rearrange this one, I is equal to H 8 pi square BC. Okay, so we know that H is constant, 8 pi square is constant, and C is constant. Therefore, I is inversely proportional to B. Okay, so if you have a bigger value of I, if you have a bigger value of I, higher value of I, that means you will have a smaller value of B because it is inversely proportional. That is what is meant by this line. So since I is inversely proportional to B, and now you know that I for polyatomic molecule is greater than I diatomic molecule. Okay, so for diatomic molecule, you will expect that you will get a bigger lah because one I is smaller, so B is bigger. But now for polyatomic, since the I is bigger, so B is smaller. Okay, therefore the spacing between the line you will expect to be much smaller due to the larger value of I. Okay, so because we remember that this one is equal to 2b, okay, the distance between the two lines is 2b. Therefore, the smaller the value of b, the smaller the distance between the line. So let's say if you have a bigger I, so in that case the inertia will be bigger. That means your line will be much closer to one another. And then if you have a much bigger inertia, then you will have maybe an overlap of the line. Therefore, it is very difficult to calculate the value of B because it is so small, and then the spectral line are more closely spaced. So this is the one that limitation in linear polyatomic molecule. And then another thing about linear polyatomic molecule is you need to have a permanent dipole to be microwave active. Therefore, carbon dioxide OCO is not active in microwave, where OCS will be active in microwave spectroscopy. Therefore, OCS is the one that will show the spectrum, where carbon dioxide will not show the spectrum. And then one thing, it is only one value for moment of inertia can be determined from a spectrum. For example, in this case, either IB or IC. Therefore, it is not possible to determine radius RCO and RCS. So if I draw this one, you know that from inertia, you will get the value of the bond length, right? So now, if you have three atoms in that linear polyatomic molecule, for example, O, C, CS, that means you have to calculate the bond length between RCO and then bond length between RCS. So if you have only one value of I, which is either IB or IC, that means you can only calculate the value of the total bond length. Therefore, it is not possible to calculate the RCO and RCS individually, because this value of inertia only allow you to calculate, I would say, the total bond length between O to S, not the individual RCO and RCS. So that's another limitation in linear polyatomic molecule. So in that case, how to measure the bond length in polyatomic molecule? So another thing that you can do is, if you have OCS, right? OCS, the only thing that you can measure the OC and also DCS is by isotopic substitution. Isotopic substitution, where in that case you can use, for example, we know that oxygen has oxygen 16, oxygen 17, and then carbon also can have 12 carbon, 13 carbon, and sulfur can have sulfur 32 and sulfur 34. So from this one, you can do a simultaneous equation to solve the equation to get the value of RCO and RCS. We remember that in the previous equation or question, the bond length R in isotope is constant, is the same. But since now you change the value of the mass, which is 16, 12, 32, 17, 13, 34, this one will give you different value of B and also different value of inertia. With that, please try these 3 questions to end this microwave topic so that we can discuss in the live session. With that, thank you.